Alright, we're going to be working with 11.2 again today. The process that we're going to be working with to start off with is called rationalizing the denominator. Basically, what we're going to be doing is we cannot have a square root in the bottom. So we're going to get rid of that. It's improper in mathematics. So we have 5 over the square root of 7, and we need to get rid of that. So there's this little trick you can do. You can multiply it by whatever the root is on the bottom here, root 7. So you multiply by root 7 over root 7. The reason we can do this is because root 7 over root 7 is 1. You can multiply any number by 1, and it gives you the same number. And so as you can see here, root 7 times root 7 is root 49, and root 49 is 7. You no longer have a radical in the square, or in the denominator. And then, let's see, 5 over root 7, we just did that, root 2 over root 3b. Alright, root 2 over root 3b, I'm going to multiply by whatever's in the radical symbol in the bottom. So this is going to be root 6b. Remember, if you have two numbers underneath the radical, you can multiply them together. And then we have root 9b squared. And you'll notice a trend here. You just get what's left in the inside. This breaks up into root 9 root b squared, which is 3 and b. So there you go. If this simplifies, sometimes the numerator simplifies. Not always, but sometimes. In this case, it does not. Okay, the next one is adding and subtracting radicals. So this is our next skill right here. What you're going to do is you're going to simplify any radical first, then you're going to combine like terms. So simplify any radical, and then basically what I call it is combining like terms. And what I mean by that is that if you have 3 root 2 plus 5 root 7 plus 2 root 2, you can combine the root 2's together. Kind of like if you had 3x plus 5y plus 2y, you could add, oops, not those, you could add, try that again. Okay, there you go. Alright, you could add those two together and get 3x plus 7y. So this is a similar concept. So you have 3 root 2 and 2 root 2, that's 5 root 2. Notice how the y's don't change. The y's didn't become y squared. Similarly here, the 2's don't add together to give you 4. It's 3 root 2 is root 2 plus root 2 plus root 2. And then you're adding root 2 plus root 2. So altogether, that is 5 root 2. The root 7 is not the same, so we don't put that. Okay, we have next example, 5 root 3 plus root 48. Now here's 5 root 3 plus 48. Here's an example where you can simplify this first. So this would be an example of utilizing step number 1. So this is going to break down into root 16 root 3. So you have 5 root 3 plus 4 root 3, and altogether that's 9 root 3. So simplify, combine like terms if possible. Okay, multiplying radical expressions is the next skill. We have root 5 times 4 minus root 20. Root 5 times 4 minus root 20. You're just going to be applying the distributive property. You can, if you have root A times root B, you multiply those two numbers together underneath the square root. Just a little reminder there for you. So the first one we have 4 root 5 minus, now here we have root 5 times 20, because they're both underneath the square root after we apply the distributive property. So that's going to be root 100, and that will simplify to 10. This has a root 5, this does not have a root 5, so we're going to leave those separated. Alright, here we have, let's see, root 7 plus 2 And then I'll just do this one over here. This one here actually is a binomial times a binomial. And to multiply binomials, we use this little box thing here. If you have not seen this, be sure to ask me or a peer. I think everybody has seen this, but I'm not sure. So you have to apply this method here. It's kind of like a binomial times a binomial from last year in algebra. We have the square root of 49. We have the square root of 14. Here I have negative 3 root 2 times root 7. So I can multiply the root 2 and the root 7 together to get root 14. And then here I have negative 3 times root 4. Okay, so I have root 49 plus root 14 minus 3 root 14 minus 3 root 2, or root 4. Okay, so that's 7. The two root 14s can combine. This is 1 root 14, so that'd be minus 3 root 14 is minus 2 root 14. And this is negative 3 times 2, which is negative 6. And then the 7 and the negative 6 are like terms, so that's 1 minus 2 root 14. Alright, I think I'm going to leave it at that. You've seen examples of all of these. Here's your assignment. Again, this is very important that you do all of them. Each of these problems are very unique. It's very essential that you can do all these problems. So if there's even one problem that you don't know how to do it here, you need to make sure that you ask me or a peer, or you look at my solution key and try to figure it out. Thank you guys for tuning in to 11.2, day 2.